Hello everybody. So now we are going to discuss the difference between these two terms that we have here on the screen, which are the units and the dimensions. And to understand the difference, I will just take a look at this table, and hopefully this table will make things clear. I'll just zoom in just to make things easy for us to see and to make things clearer. So in this table, let's just focus on the first part, which is the basic dimensions part. Here you'd see that we have three columns. One of them is called quantity, one is called dimensions, and one is for units. The quantity, we have length, time, mass, and temperature. And for each one of them, it's given a symbol. So you have length L, time T, mass M, temperature T, or sometimes it's defined as a theta. So this is how we define the dimension of length, time, mass, and temperature. This dimension can be described by many units. I can use mass, meter, I can use centimeter, foot, inch, mile, you can have kilometer, you can have millimeter, micron. All of these are units for length. So the same for time. You have the dimension of time is t, and this time can be expressed in minute, second, hour, year, millisecond, microsecond. They're all units of time. For the mass, it has a dimension m, and this mass can be defined or described by many units like kilogram, gram, pound, ton, milligram, whatever the units. Then these are all units of mass. The temperature, you have Celsius, Kelvin, Fahrenheit, and they are all dimensions of T. So the dimension represents the quantity. Is it length? Is it mass? Is it time? Is it temperature? And these are called the dimensions. And this doesn't depend on the unit used. This dimension, as I just mentioned, can be expressed in any of the units of mass, of length. This can be expressed in any units of time. The same for mass. The same for temperature. So it doesn't matter. It doesn't make any difference. They all have the same dimension, which is L, T, M, or T, whatever the dimension that we are dealing with. We call these the basic dimensions because they are the very, very basic ones. They don't depend on anything else. Length is length. It doesn't depend on anything else. Time is the same. We have other, what we call the combined dimensions, which are combination of one or more of the basic dimensions. So for example, here for the volume, it is L power 3. L power 3, it is L multiplied by L multiplied by L. It can be meter cube, centimeter cube, foot cube, whatever the unit of, or liter, milliliter, whatever the unit that we can use. The velocity, it's distance over time or length over time. So it's LT per minus 1. Density is mass over volume. It's ML per minus 3. Again, for each one of them, you have multiple units. So the dimension is a property that can be measured, such as length, time, mass, or temperature. They're called the basic dimension. There are some other dimensions that are called the combined dimensions, which are calculated by multiplying or dividing the basic dimensions. The dimensions of, or a dimension of a quantity is always the same, and this is what we said here, that it's the same dimension, and it can be expressed in any suitable unit. It doesn't matter. It doesn't change the dimension. So as we said here, the velocity is LT minus 1. You can use centimeter per second, meter per second, foot per hour, kilometer per hour, mile per hour, whatever the unit that you want. They're all units of velocity. But the dimension is going to be the same. Right. So one thing that we need to know also about the units is that they can be treated like algebraic variables. Means that we can add, subtract, multiply, or divide units as we do for numbers. So for example, we will deal with two cases: the addition, subtraction, and multiplication and division. For addition and subtractions, the two quantities that are being added or subtracted must have the same units. For example, if I have 3 hours minus 1 hour, it's 2 hours. It's exactly like saying that 3x minus x equals 2x. So it's exactly the same. But if the units are not the same, then the process or the calculation is not possible. If you say 5 hours minus 2 meters, it's not right. Even for the units with the same dimensions, and here I have dimension of time, the dimension of length. Here in these two cases, meter and inch are dimensions of length, but these are not the same units. So you have to either convert the meter into inch or the inch into meter in order to be able to do the subtraction. For multiplication, it's and division, we don't have any limitations like the addition and subtraction. So I can divide mass by volume to get the density. You divide the number and the units. So 3 divided by 0.5 is 6. Kilogram divided by meter cube is kilogram per meter cube. The same here, 30 newtons multiplied by 20 meter is 60 newton multiplied by meter. We multiply the two numbers and the two units. If you say 0.5 meter per second multiplied by 200 second, you get the distance. The second will cancel out, and you multiply 0.5 by 200 is 100, and you end up with only meter. You can even divide two similar units. And for example, if I divide mass by mass with the same units, you get what we call a dimensionless quantity. This is why I mentioned before that we have we must write the units of dimensional quantities. So I said dimensional because this is dimensionless. You don't have any units here. So this is an important thing to understand, which is the difference between units and dimensions. Next time we will be discussing the systems of units, which is a very important thing as well. So I'll see you then, inshallah. Goodbye.